Archimedes' principle. We're all aware of the fact that some objects float in water while others sink. Let's look at a balloon. Do you know what makes a balloon float on water? Well, it's the upward force exerted by water that makes the balloon float. To experience this, try pushing the balloon underwater. You will feel an upward force that makes it difficult to push the balloon down. Now release the balloon, it bounces back to the surface. What happens here is that the applied force acts in the downward direction, pushing the balloon down, but the water exerts an upward force on the balloon, pushing it up. This upward force exerted by water on the balloon is known as upthrust or buoyancy, and the upward force is called the buoyant force. Have you ever wondered why an iron nail sinks while a huge iron ship floats on water? Let's see. The iron nail sinks as it is solid and compact with less volume in water, and its density is greater than water. Thus, the upthrust exerted by water on the nail is less than the weight of the nail. This causes it to sink. An iron ship floats as it is hollow, filled with air and occupies more volume in water, and its density is less than water. Thus, the upthrust exerted by water on the ship is greater than the weight of the ship, letting it float. These examples indicate that the magnitude of the buoyant force depends on the volume V of the immersed part of the body, the density ρ of the fluid, and the acceleration due to gravity G. Thus, upthrust or buoyant force is equal to V ρ G. In general, an object experiences a loss of weight in water due to the upthrust, and it is equal to the weight of water displaced by it. This is better answered using the law of buoyancy, also known as the Archimedes principle, named after the Greek scientist who discovered it. Archimedes' principle states that when an object is immersed in a liquid, the apparent loss of weight of an object is equal to the upthrust, and this is also equal to the weight of the liquid displaced. We see the uses of this principle in our daily lives. Ever caught a fish with a fishing line? When pulling the line, you would have felt the weight of the fish in water is lighter than when the fish has surfaced. Say the weight of the fish in water is 4 kilos. Its approximate weight outside would be 5 kilos. Well, the water level too has come down. This difference in the volume of water level will equal the loss in weight of the fish when in water. That is, the weight of the fish when outside minus its weight when immersed in water equals the loss in weight of the fish. So the loss in weight of the fish will equal the weight of the decreased water. This is because the upthrust or buoyant force is equal to the weight of the decreased amount of water. Thus, Archimedes' principle is verified. Certain technologies today work based on the Archimedes principle. To name a few, the designing of ships and submarines, hydrometer is used to find the specific gravity of liquid, and lactometers used to determine purity of milk. Things to remember. The upward force exerted by a fluid is called upthrust or buoyant force. Upthrust or buoyant force equals V ρ G. Archimedes' principle states that when a body is partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Archimedes' principle is also known as the law of buoyancy.